This is to help determine what kind of a triangle is formed from 3 given sides. This follows along with our Common Core 2 packet, section 4, found on page 4. So if you're given 3 sides of a triangle, we want to see what kind of a, given 3 sides, I'm going to represent 3 sides here. What kind of triangle will this form? Now the answers that we could have are either they can make a right triangle, an acute triangle, or an obtuse triangle. So remember, anytime you're given 3 sides for a triangle, as long as the 2 smaller sides are longer than the longest side given, we will be able to form a triangle. So that's easy to see here. So we know that we can have a triangle. Well, what kind of a triangle will we have? Well, the strategy in doing these is we will take the 2 smaller sides and form a right triangle. So in this case, I'm just going to visually show. I'm going to attach these and make it at 90 degrees. So mathematically, what we have for this example, we have a side that's 6 and we have a side that's 8. So we would calculate using Pythagorean theorem what the other side would be to make a right triangle. So 6 squared plus 8 squared equals, that is 36 plus 64, which is 100. So we have a 10 here. So these 3 pieces, these 3 legs, will form a right triangle. This is a 3, 4, 5 triangle in disguise, just scaled by a factor of 2. So when your side's given, so we have 2, 4, 6, 8, 10, this was our 10. So this matches Pythagorean theorem and solves it. So let's consider what would happen if we did not have a right triangle. Well, you still did a calculation to figure out what your hypothetical hypotenuse, what your hypothetical long side of your triangle would be to make a right triangle. So this is always going to be true for your Pythagorean theorem. Now let's choose a side that is longer than what we have and visually see what happens to our triangle as we remove the length that's required to form a right triangle, and I want to insert this so it touches both sides. Well, what do I have to do? I have to spread these, I have to widen this angle. So now this is a 12. So notice, in order for the 12 to touch the 2 legs of my triangle, I had to break my 90 degree and open it wider. And now this angle is greater than 90, so this is an obtuse triangle. So when our given side is longer than the hypothetical length you would need for a right triangle, we would have the situation to form an obtuse triangle. Let's look at the situation where the side we're going to replace our right triangle. Let's reform. So here's your 2 sides, put it 90 degrees from each other, so this again fits back to where we were with our right triangle. This is our 3, 4, 5, or 6, 8, 10. They're scaled the same, they're similar. Now we're going to replace it with a shorter length. And notice I'm still using a length that's longer. You always do this with the 2 smaller sides if your results to come out right. So now when I try to fit this in place, It's too small. So I need to contract these sides to get that to touch. So by contracting, now I just have closed this angle. So now it is less than 90. So each of these three angles are less than 90. So the type of triangle that forms is an acute triangle. Let's look at some numbers just to make sure we're not having too much fun here. So we'll look at an example of if we're given a 3, a 5, and a 6. So these are our two smaller sides. 3 plus 5 is 8. That is more than 6. So that's going to work. So 3 squared plus 5 squared is, that's 3 squared is 9. 5 squared is 25. So that gives us 34. And 6 is the third side. This is the hypothetical right triangle. This is our c squared. So we're going to compare that to what we're given with the 6. So I don't have to take the square root of this to solve this problem. I can square my 6 and compare those two numbers. So 6 squared is 36. So here's where I'm making the comparison. This is the side I'm given. This is what it would be if it was right. So I'm given a longer side. So that's going to open it wider and make an obtuse angle. You can visualize this. You can simply take your hand and imagine your two legs forming your right triangle, and as you try to fit your extra length in, when you think of a longer side, you spread your fingers apart wider, and you see that obtuse angle opening up between your thumb and finger. If you put a shorter side in there, you close your fingers together and you represent that acute angle. So hopefully that should make it easier for you to determine what kind of a triangle is formed with three given sides.